All right, kiddos. So here we go. Welcome, welcome. This is the beginning of the adventure of online learning. Go team. We are picking up in, well, miss you guys. It's really dark. If I could switch my camera, I probably can if I think about it. I mean, some of you guys have been in here when the lights actually go out, but it's a little lonely around here. Teachers had a meeting this morning, and then I and a few others were running around and being available and trying to help people figure some things out. Otherwise, we're just able to be on campus to be working on things and recording. So anyway, this might eventually move to being at my house, but for right now, you guys should see my setup. It's quite well, you can see the normal stuff behind me, but I have like the webcam with my calculator. Anyway, my iPad hooked in. We're going to try to do what we can, and I'm trying to have as many modalities to make it as personable as normal-ish. What I'm thinking of as far as vision, I know, we're supposed to be doing section 6.2. Don't worry, we will. And like normal, when we start a new section, I'm going to do something random from 6.1 to start off. To do like an AP FRQ. That's coming in just a moment. But just since it's kind of like the intro and the beginning of like what life is going to look like as far as us doing online stuff, I am planning on making lecture videos. And as I make those lecture videos, I'm probably going to be assigning the lecture videos. I know, not quite what we anticipated, but assigning the lecture videos to Google Classroom through something cool called Edpuzzle. I think French kids, Spanish kids, you might use this too. But assigning the lecture videos, because it's going to be like your attendance. Like, I'm not going to make you, anyway, let me finish the thought and then I'll come back. Plus, you guys are my guinea pigs because you're the first class that I'm doing like an official lecture right now. So that's fun. And right now it is, what, 6:51 on Monday night. Miss you guys. Hope you're doing well. But we will be able to connect, like not just me talking pretend at you, but kind of at you, but not. I'm kind of by myself in the room too. But my plan is to post the lecture video through Edpuzzle where you have to watch it, and that's how you get like attendance. I mean, I'm not, but like participation. I'll give you points for watching the video. I'll give you zeros for not watching the video. Like I can see if you watched it or not. I can stop you from pausing it. That's the annoying part, because some of you might want to just speed up a lot of this annoying stuff. So I'm going to try to trim the fat and not just be randomly talking at you. And I'm going to try to pretty much, like besides right now, be presenting the lecture and having all of the things ready and set up. Like my calculator already has the function put in, my iPad already has this, and my computer already has like windows open. So it's a little different than class in that I can try to like just trim it down, the short, sweet version of each of the lessons. Just think I am doing like 1 to 2 to 3 days of a lesson all in one video, which is a little weird, I know. And so we're gonna have to figure out, you guys are gonna have to collaborate with me. If in Edpuzzle you can like watch part way, and then if you don't want to finish it that night, you can like stop and then keep going and eventually get the whole thing watched. We're gonna have to talk. Wait, how are we gonna talk? Well, okay, as you know, you can comment on Google Classroom. Homeworks as they're due. Remember, I'm posting the evens online so you guys can be grading it. Sorry, I'm like staring at myself because it's just, I'm moving. I should stare at the camera. I'm learning. But you guys are supposed to grade your homework, and they're supposed to be commenting in Google Classroom with the homework questions that you have questions on, so we can go over it. I mean, I am gonna have my webcam. Eventually, I might just bring all my textbooks home so we can look at it that way. We'll figure life out. We'll get there. But remember, you can be commenting homework questions. That's one way of interacting with me. But I'm planning on just having that video post up like the night before, or maybe the morning of, like when an assignment would normally post. I'm thinking the night before, just because morning of, like some of you guys would rather just stay up late the night before and start watching it. I'm not going to require you. Remember, I'm going to require you to watch the videos, but that's kind of on your own. I'm not going to require you to be in my classroom every day at your class period time. However, even though I'm not going to require you to always be there, I am going to try to, whether I'm home or whether I'm here, teachers are supposed to be available to you between 8 and 3:30 every normal school day, Monday through Friday. I have plenty of work to be working on. You guys should see my grading. That's not even counting Google Classroom. So what I'm thinking is, like right now, I'm recording through Zoom. I'm recording myself because I can tap into all these different mediums as far as my webcam and as far as my iPad and as far as my computer. And you can see my face. It's more fun than a blank screen. but I can also go live in Zoom. So what I'm thinking, what I'm planning is maybe, it depends on whether I have to do like unique links every single day, but somehow posting for you guys, and then maybe like once it expires, just deleting it. But posting in the announcements feed, like where I am as far as my link code, and I'm planning on being live every Monday through Friday class period, being live, being available, and working pretty much. Because I will be working on grading, working on this, working on that, working on Google Classroom, working on updating RenWeb, working on all the things I'm really behind on right now since we've been trying to figure out how to get this thing rolling. I'm gonna be working, but then if you guys like pop in, that's pretty cool because I can see you. There's gonna be like a ding dong that I can hear and be like, oh, someone's here, and be like, hey, how you doing? I can check in. If you have a webcam, a microphone, that'd be awesome. If not, you can just like type in chat. Meaning I'm here with my iPad and with my calculator and with my textbook theoretically, and I'll just be waiting. Like I basically do every day after school, just maybe not as distracted. So maybe I'll actually be getting work done. If you're not, that's not a guilt trip at all. But if you're not in there, like I'll be working, and you guys, like as if you could pop into my room or into a college professor's office hours if they're available during a certain time. My plan is to be available to you during your normal class periods. So period 1 from, what is it, from 8, maybe 8:05 to 8:53, and for period 6 after lunch. I will not necessarily do the whole CalcChat tutor from like, hey, 4 to midnight, I'll be online. I'll be online during your class period. And that's something if another teacher needs you to check in or something else. Anyway, I'm dragging this out longer than I meant to, but it's basically the intro to everything we're doing. So anyway, lecture videos will show up via Google Classroom assignments. You have to watch the video, and then you have your assignments due like normal. And in those assignments, you're going to have the evens that are posted. And then if there are any further examples, like I do the lecture video and I'm like, you know what, I left out these examples, they could be really helpful. Or if someone has a question, I end up recording like a baby tutorial, not during a live session. I'm not going to be recording live because I mean, your guys' faces could pop up, your voices could pop up, and most of you are minors, and that could be illegal for me just to randomly be recording you and posting it online. So the live sessions won't be recorded, but if someone like types a question in the homework comments and I end up making a tutorial, I might post that in the assignment as in like the assignment itself. But otherwise, I'll just be available. I'll be online during your class period, Monday through Friday. If not, I'll give you a heads up, or there just won't be a link that appears. But feel free, guys, to reach out to me on Google Classroom. Once again, some of your classmates have my phone number. You guys can always text me. But yeah, let's get on with the lesson, because right now I'm kind of bored with myself talking. So let's get into section 6.2, but as I already said, oh, go team, we're gonna actually do an FRQ from 6.1. So as I'm getting my iPad connected, it's gonna take a little second here. As I get my iPad connected, you guys need to have your graphing calculator, and we're going to do an AP FRQ, and it should be popping up on your screen. Look at here. It should be popping up on your screen right now as far as the FRQ that we're looking at. Now, guys, FRQs, and I can show you kind of down below. I don't want to show you all the answers. FRQs have multiple parts, right? Like an A and a B and a C. And if you guys notice down here in the multiple parts, this guy, he has this word area, this keyword area. Ooh, that's not showing up so good. Let me do like a deeper highlighter and see if that helps just a little bit. There we go. He has this area guy right down here, but then he also has this volume and then this other one that has to do with like a trickier area. Oh, bummer, it's not showing up at all. Let's see if it kind of catches up. I'm not sure if someone else is trying to use the Wi-Fi right now. Oh, it just took me off. Okay, hold on. I thought since I was here at 6:11, no one else would be, but let's try again. Take 2. Mr. Rice's Apple TV is on. That's exciting. Okay, as this is trying to connect, I guess I should have been doing this while I was talking randomly. You know, you live and learn. You live and learn. That's okay. Hopefully you guys are staying out of the rain. Hopefully you have your necessities. I don't want to make the toilet paper jokes. I'm not going to, because to be honest, I'm pretty annoyed by it. But, uh-oh. If you guys celebrated Pi Day, if you haven't seen in Google Classroom yet, there is definitely Pi Day bonus, and I did not make a deadline on it, which is pretty awesome, because that means that you guys can still celebrate Pi Day, even though technically March 14th is over. And you can't get the 1:59 snapshot with the cool timestamp and all that jazz, but that doesn't mean that, don't look at the answer. Okay, good. That doesn't mean that you can't still celebrate and you can't still get your bonus. I did not put a deadline on that. That's a good announcement that I should have thought of. I don't know where to be looking. Okay. Good thing I'm not an actor. So I kind of have to be every day for you guys. And I should turn my sound off my phone. Okay, so as we're looking, I was trying to show you guys, and now I can actually show you, I think. Don't look. Okay, that the first one has this word area right there. Now it's kind of working. Second one has this big word volume, and the third one has this big word area. Now this was from a few years ago. This was 2006. And you guys might be like, man, she's so outdated. I get it, kind of, sort of, but I also know calculus, and I know that some things in some ways never change. So I don't apologize for using a 2006 FRQ, not at all, because there are some particularly hard things, there's some tricky things in this FRQ that, to be honest, they still love to trick you with. Like, hey, there's a line L, and we tell you nothing about it besides the fact that it's tangent to the curve at 0, and you have to make the line. Oh my goodness, in calculus, you have to make a line, y equals mx plus b, point slope form, knowing the slope and knowing the point and the slope is a derivative, mind blown. Anyway, coming back. So we're gonna go ahead and just tackle part A today. We're not doing an entire FRQ because this entire chapter, if you guys remember, I know, only sections 1, 2. I said 6.3, but it's actually 6.1, 6.2a, and 6.2b, really just 2 sections. Still gonna take us like a week and a half. Let's not even talk about it right now. I don't really want to think about it. But long story short, we're just going to tackle part A because we haven't really learned how to do the rest of it. And even though we could tackle part C, let's just do A. So you guys have your graphing calculators. Hopefully they're out, they're open, they're ready. We're going to be able to use them, which is an awesome thing. Remember, sometimes you can, which is why in your homework, if you're setting up these integral expressions for finding these geometric measurements, area, volume, remember, part of it is just getting the right setup. So plug that into your graphing calculator and then check it with the back of the book and see if it works. What if they didn't write a decimal in their answer? Okay, plug their answer in, compare it to your decimal. See if you have the setup right. And then every now and then, I mean, do a couple by hand. You know what I said, every other one, every third one. Do some by hand to make sure that you kind of know what's going on. And I feel like, ouch, and I'm gonna sit up straight. Okay. So looking at this FRQ, we have a function, and if I were you guys during all this random time of me talking, maybe you were plugging this function into your calculator. That would be an awesome video. And we have R being the region that you guys can see right over here as far as, and I didn't want to use that pen, let's use the highlighter, as far as this shaded region right over here, okay? And if you look at this region R, I mean, they might give it to us in words, but they also gave us a picture. This region R totally signifies the area bounded by the curve F and the x-axis, right? The area of the region bounded by the curve and the x-axis, and technically the y-axis too. So a couple reminders about the x and y-axis. Remember the x-axis, I really wish I could point at this and that my computer would speed up just a little bit, or the connection, even though it's hardwired. I'm just complaining. It's okay. We're learning. Remember that the x-axis is y equals 0, whereas the y-axis is x equals 0. Okay, give me just a second because this really is being annoying. Meanwhile, you guys can be plugging into your calculator your function, and I can go ahead and try to show that to you if this will actually pop up and work. Let's go ahead and stop this share. Let me try sharing my webcam so you can see how I put it in. Although, hopefully it's not too bad. Pause if you guys haven't yet. Throw that function into your graphing calculator. And if I were you, as you're throwing this function into your graphing calculator, I'm just giving you guys working, actually, I've already done this. I would go ahead and get a nice window. I've started in Zoom Standard. I've zoomed in, and then I've adjusted a little bit so I can see the full curve, which helps a lot. But we also are going to need to find this 0, because if you can pause me right now, you can rewind a little bit. If you look at that region R, it's technically this region right here, even though like the picture is a little different as far as how they did their window. but the region R is right here, which is bounded by the x-axis, the y-axis, and then you need this. I mean, this one is x equals 0, but I need this intersection point. So if I were you guys, once you get that function into your calculator, you're going to want to use your 0. I mean, if I were you guys, I get bored, or I don't know what the right word that is. I get annoyed with having to, like, if my cursor's way over here, like, oh, scroll, 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 scroll. I'd rather do like, hey, -2 is definitely right. -2 is definitely to the left. -1 is definitely to the right. Yes, whatever. It's the only one in between. Go find it. Hey, cool. Get your 0 if you need to. Rewind and watch my steps and what I did. But then you want to go ahead and do second, quit, stow this guy and stow him as an A or a B or a C. Stow that guy because we're totally going to use him in just a bit. Once again, you're getting that X value of the 0 so that we can use it in our calculator in just a second. Now, I'm going to go ahead and try to get my iPad back on because I was frankly writing and it wasn't keeping up. But you guys go ahead and get that function into your calculator. Try to get that 0. If you need to, pause and rewind me. And then you can just go ahead and skip ahead a bit as well. Come on, iPad. No one's supposed to be on the network right now. Let's see if I can get him to come back. Come back, come back. Okay, at least the picture's there. All right, pause me if you don't have your function in your calculator and your 0 stowed as a variable, or go back and review this. But let's go ahead and keep going. And as we keep going, let me get back into my presentation mode here. So there we go. We have our x equals 0, our y equals 0. And as I just talked about, we were able to find in our graphing calculator this little intersection point right here. And this little intersection point right here is going to be, let's see, f of x is equal to 0 at a, which is, I stowed it as a, so I'm going ahead and writing a. That way, I don't know, I have this random variable assigned to be what I want it to be, and I can go ahead and use that letter A any other time I need it in the problem. I'm going to go ahead and throw in that point that I just showed you guys on my graphing calculator, which, now remember, the final answer is 3 decimal places, but before that final answer, we're supposed to keep more. So I'm going to put -1.37312 ... That's sufficient for them being like, okay, she found the actual one. So as we're looking at the area of our region, so guys, check it. As you're looking at, let me see if I can change the color of this to be a little bit nicer. We have it cut off on this side with x equals my A, on this side with x equals 0. And then if we're just trying to think of like top minus bottom, we can go ahead and just say, okay, who's on top this entire time? The function. Who's on bottom the entire time? The axis. And so if the function's on top the entire time, if the axis is on bottom the entire time, I'll just see in the top of my head, then I can use it. I can use it as we did in section 6.1 with the definite integral from a to b of the top minus the bottom. And so in this case, it's actually not going to be that complicated because my area, more specifically my area of R, is going to equal my definite integral from, as we talked about, a is the guy on this left side, the x bound. 0 is the guy on this side. And so I can go from a to 0 of my function f of x. If you want to be snazzy, you can do -0 because that is technically the bottom, and then dx. That one looks like a 6, so let me get rid of that just because it's not a 6, it's a 0. And that was a little too big. Let's make it a little bit smaller. But there we go. Now, the joy of this whole thing is it's a calculator FRQ. So now that I've written properly the exact expression I'm going to do in my calculator, all I have to do, let me go get my calculator, is to plug in that integral expression. So you guys go ahead and hopefully you have that totally ready to go as I pull up my calculator. In that, you're just going to go ahead and then you can scroll down and take all that the integral, which is kind of annoying. Or remember, we have the cool shortcut alpha window. In that alpha window, there's my integral. I can go from the a that I already plugged in, 0. Remember, f of x It's in my Y1, so I can use the alpha tracer if you want to. Once again, there is that long way of vars, Y vars, function. We're in function mode, Y1. But I don't think I already have it. Remember, you can always hit second over to jump to the end of the line or second back to get to the beginning. I'm just trying to go get my DX to finish the problem off. And the great thing about this is that I can go ahead and say, sweet, 2.903 is my final answer. I don't need to show any work because this was a calculator problem. And so all I had to do was just show my basic integral, because hopefully they'll give me points for like knowing what I'm doing. And then I'm just getting my iPad back up. All I need to do is write that final answer rounded to 3 decimal places. So all I'm going to do right now is just say sweet equals. I have my pen up, and I think I do. Equals that 2.903. So hopefully that makes sense. Go ahead and comment if it doesn't. But that was just our quick little like recap of 6.1. You guys hadn't asked, I don't think, any homework questions yet. I haven't been available for a math lab yet, so I'm not sure exactly how you did last night as far as, I mean, right now it's tonight. Some of you guys are still finishing, I'm sure. Maybe you realized I changed the deadline from 11:59 to 8 a.m. tomorrow morning. You're welcome. To give you just a little bit of extra time in case you guys procrastinated that assignment. But 6.1, hopefully that made pretty good sense as far as our forever card. And as far as just the idea of top minus bottom. And this one was pretty easy because the bottom was the axis, so it wasn't that crazy. But we need to go ahead and move on. If you guys want, I can show you really quickly that that FRQ was worth 2 points. Hopefully the screen is, there you go, scrolling. It's worth 2 points in that we have 1 point for the correct setup of the integral, and then we have 1 point for the final answer. There is probably going to be some place lower where they do give us points for talking about, now they named it point P, whatever, I named it point A, it doesn't really matter, but what you see is that they put that point P right there in that integral bound. So from P to 0, whereas I did A to 0 of f of x dx, and then check it, just write the final answer because your calculator did all the work for you. You just knew the concept and you knew how to apply your knowledge to get the answer. So that's just kind of a cool little, hey, you can do more of AP FRQs than you were able to before section 6.1. That's something where I'll be in online math lab, or I'll be in the live sessions during your class break. You can ask me questions and I don't need to show you the evens, those are already in Google Classroom. Why? Well, why are there so many slices of so many slices of objects on the screen right now? I see a slice of an orange, a slice of a tomato, a slice of a lime, a watermelon, a bread. What are the shapes? That's something where I would normally throw it out to you guys and have you answer, but I see circles, like Dora the Explorer. I see circles, I see semicircles, I see, okay, a strawberry, I have no idea. The bread is roughly rectangular-ish, a little bit squished, I know. The watermelon, roughly triangular. Long story short, volume measures 3-dimensional shapes. Our world is full of 3-dimensional shapes, but are all the objects in our world strictly spherical, cylindrical, triangular, rectangular? The answer is definitely no. Especially a lot of things of beauty. Think of like, was it Mr. Hogan or was it, oh, the Potter lady that came last year? Anything that's made on a potter's wheel is not gonna, okay, maybe you can make a perfect cylinder, but anything else is gonna be a different shape. Think of all like those curvy vases and things like that. Or like the pitchers or different things on a potter's wheel. Like none of them are gonna be one of those just boring geometric figures, except maybe a cylinder if they make it perfectly. But I mean, that's just one example, but so many 3-dimensional objects, especially those that are spun, are not strictly geometric figures. So how are we able to, just think like an airplane, how are we able to think about the volume of irregular figures? And that's where section 6.2 comes in. I do want to show you guys really quickly and the iPad's still catching up anyway, really quickly, a few things online as we get ready to start this. I wish I could, let's see, I wish I could have you guys taking notes while I switch back and forth. You know what? I probably could. I would just have to have this open. Anyway, sorry. Yes, troubleshooting. Yes, trying to think through exactly how all this is going to work. But I can pull up, I was going to show you guys something really weird on your Google Classroom. It should be showing up on the screen right now. Once the homework does post, you guys will see that homework starts at number 70 and 71. No, that was not a mistake. That's on purpose. This idea of solving for volumes by cross sections. And once again, I can pull up, I'm pretty sure. Here we go is exactly the title for all of this entire adventure. I'm gonna go ahead and pull up, that way this can be, I think, frozen on the screen while I get ready to get my iPad back, etc. But you guys can pause right here and take notes if you need to, if I can find the correct screen and if my computer catches up with what I'm trying to do. Network issues, okay, it's okay. I'm gonna be troubleshooting here for a little bit, so if you guys wanna take a picture of this and be writing it down, or if you want to, it might not be a bad idea to have your phone, just because there are gonna be lag times, I think, just with me going back and forth, iPad and computer. You can take a screenshot of this real quick, or you can pause it and then just kind of catch up, which is another reason why I might let you skip around in the videos on Edpuzzle, but I still want you to watch them, so I'm still gonna need to see they got to the end, but I might let you skip around a little bit. But you guys can be taking notes as I kind of talk about, it's weird in Google Classroom because for your assignment, oh, hey, forever cards. The next one, forever number 44, the last one we did was area between curves. That's what 6-1 was on. And now we have volume by cross sections. These cross sections, otherwise known volume by slicing or cross-sectional areas or cross-section slicing. I mean, if you take a cross-section of something, it technically is a slice. Hence why I had bread, I had tomatoes, I had limes, I had watermelon, things that you slice, right? Or that come in slices. This homework is weird because they don't talk about that topic until the very end of homework in the 70s, but in my mind, it's actually the entire foundation of what section 6.2 is. And as I said, there's a 6.2a and a 6.2b. 6.2a is what this whole slicing cross-sectional thing is about. 6.2b says, okay, let's specifically talk about the ones that have been spun, that were somehow generated by spinning, by rotating, by revolving. Hyperboloids, ellipsoids, paraboloids. Oh my goodness, it's like last year all over again, but don't worry, it's gonna be, can't say it's gonna be simpler, but it's gonna be a bit more formulaic than last year. And last year was really just to get your brains visualizing this idea of spinning. Our book didn't even have that. I actually introduced it and brought it in from another book that I used to use. But it was literally to build you up for right now being able to visualize. So you guys hopefully are having notes, volumes by slices, and I was just showing you what's going on as far as the forever cards. We do have that new forever card if you want to go ahead and screenshot it. It's coming up in our notes in just a second. We also have, my foot's tingling. We also have our homework in a weird order, but that's on purpose. Please do it in that order. And then, ooh, we have some cool things coming as far as I have a Google search, calculus volume by cross-section project. Oh, that'd be a fun one for us to do. We just never have time. I guess because I talk too much, or you talk too much, or both. But either way, love you guys. We're gonna come back to this and see, why do I have all these random, there's a Super Mario's mustache, what? And a minion, what? Anyway, and it's all underneath the guise of calculus. We're gonna come back to that in just a bit, but let's get back into our notes for a little while, and then we'll come back and see what's going on. So getting back into our notes, you guys might be writing your forever, you might be finishing up that page of notes. The note says, find volumes of three-dimensional figures using integration, and it's specifically helpful, not that it doesn't do geometric solids, but it's specifically helpful for those solids that, no, it's not showing up at all. For those solids that are irregular, we would call them, or non-geometric. Cross sections is, as I have written in the notes, cross sections is defined to be slices of three-dimensional figures. So like you were thinking as far as, or you were seeing with the bread and the watermelon, that's a very common, as I scroll through what you guys saw just a second ago, those student projects, you'll see some I think there's one picture of watermelon, there's one picture of actually slicing bread. A lot of calculus teachers use this as far as trying to illustrate this whole idea of cross-sectional slices, volume by slicing, et cetera, et cetera. Let me see if I can get my iPad to load. I would pause the recorder. It's just not quite as nice as the one in class because I am juggling a bit more. So we'll try a little bit longer. But then the second bullet point underneath cross sections is underneath the idea of slices. Through integration, we can combine all the areas, all these two-dimensional areas, all these areas to accumulate. That's a huge word in integration. You're accumulating infinitesimally thin slices, whether infinitesimally thin rectangles, or in this sense, infinitesimally thin slices. Infinitesimally thin slices in order to, I'm gonna try to turn off and on my Wi-Fi, in order to accumulate. So accumulating infinitesimally thin rectangles, which are ultimately lines, and then infinitesimally thin now slices to get the whole or to get the volume. I'm not sure if someone else, if some other teacher is trying to use the Wi-Fi right now. I thought I would have the corner on the market, but maybe not. I might need to switch to a different network, in which case this would be a bit of a problem because I've already done a lot of work on here. What do you guys think? Should we start cheering for what would Doris say in order to make us cheer for what we want to happen? Come on, little computer, you can do it. I'm gonna go ahead and try to pause the recording just for a bit, and I'll get back to you guys in just 1 second.